Hello, my name is Tim Vehling, and I'm a master's student at Lakehead University in Thunder Bay. Lakehead University in Thunder Bay and the Neebing River are located on the traditional lands of the Fort William First Nation, signatory to the Robinson-Superior Treaty of 1850. My project of identifying significant groundwater recharge areas and modeling of surface and subsurface water balance of the Neebing River is part of a provincial project to better understand our watersheds and the impacts of climate change. The Neebing River is a partially rural, partially urban stream that eventually empties into Lake Superior. The watershed encompasses about 227 square kilometers and is located mostly to the west of Thunder Bay and including parts of the city's southern core. The location of the Climate Station from Environment Canada and the Water Survey Canada stations are indicated on this map of the Neebing River watershed. The data from these stations was used for this project. The research questions from our project are: where are the significant groundwater recharge areas within the Neebing River watershed? These areas have an above-average contribution to the groundwater recharge. These areas also need to be identified and considered for future development considerations within the area. What is the water balance for surface and subsurface water in the Neebing River watershed? And what are the seasonal and annual patterns? This leads to the three main components of the project, which are thematic mapping of the significant groundwater recharge areas, modeling seasonal and annual patterns of groundwater and surface water interactions, and sampling as verification of the modeled relationship between groundwater and surface water. The methodology for thematic mapping. An infiltration grid based on topography, land cover, and soil type will be developed to identify and map the significant groundwater recharge areas. The slope, the makeup of the soils, and the land cover type influence how well water can be absorbed and infiltrate the Earth's surface. The modeling of surface and subsurface water balance requires several climatic and hydrologic variables and indicators. This temporal analysis requires at least 10 years of data, where I'm looking at 2008 to 2017 or 2021. A correlation analysis using linear regression, Mann-Kendall's trend test, Spearman's rank, and Kendall's rank will be used to identify any relationship between the variables on both a seasonal and annual timescale. Isotopic sampling will be used to quantify groundwater contribution to stream flow. This is to validate the modeled estimate of groundwater contribution to stream flow. We used 4 sampling sites throughout the watershed for spatial variability of environmental impacts. Additional data such as temperature, pH, and conductivity were collected to aid the interpretation of the results. Data collection was from summer 2021 until December 2021. I would like to thank you for your time and acknowledge and thank my committee and supervisors at Lakehead University and the support we received from the MECP and the co-op funding. Thank you very much.